The underwater engine of the outer Great Barrier Reef does not sleep, but on a blindingly hot Tuesday afternoon 50 kilometers off Cairns, it falls completely silent. Jack Sullivan cuts his patrol vessel's twin outboards, letting the hull drift into the glassy turquoise expanse of the Coral Sea. For 12 years as a reef ranger, he has learned the rhythmic language of this biological masterpiece. 2,300 kilometers of living structure down the Queensland coast. A healthy coral shoal hums with life. The acoustic static of snapping shrimp, grazing parrotfish, and territorial damselfish. But as Jack rolls backward over the gunwale and descends 20 feet into a sun-drenched channel, the soundscape that greets him is not a symphony, it is an absolute vacuum. He floats through an apocalyptic wasteland of stark, blinding white. Intricate thickets of staghorn and sprawling tables of plate coral have been entirely stripped of living tissue, transformed into a cemetery of bare limestone skeletons. Then he sees the executioner. Crawling across a collapsing plate coral is a creature that looks less like a marine animal and more like a medieval weapon, a crown-of-thorns starfish. Nearly half a meter across, it bristles with 20 venomous arms and hundreds of needle-sharp, tissue-dissolving spines. As Jack watches, it averts its own stomach directly against the coral, digesting living polyps alive, leaving nothing behind but bleached bone-white silence. This single predator is not an isolated anomaly, it is a vanguard. Looking across the deeper drop-off where the reef face plunges into the dark blue of the open ocean, Jack watches a literal blanket of thorns advancing up the continental shelf. Tens of thousands of these venomous echinoderms are crawling over one another, a slow-motion carpet of spikes that turns the vibrant, colored architecture of the reef into an eroded, lifeless desert in a matter of hours. The sheer speed of the destruction is mesmerizing. When an outbreak of this scale locks onto a reef system, the consequences ripple instantly through the entire marine hierarchy. Brightly colored neon damselfish, intricate butterfly fish, and agile wrasses find their microhabitats dissolved, exposing them to open-water predators or forcing them to starve in the barren ruins. Yet, on that very same afternoon, as Jack swims further into the heart of the devastated sector, he encounters an ecological contradiction that breaks every established rule of marine biology. In the exact center of the worst hit zone, where every surrounding structure has been systematically stripped bare, stands a single isolated sanctuary. A spectacular oasis of staghorn and delicate needle coral thrives in pristine, vibrant shades of amber, purple, and green, completely untouched by the carnage. Stranger still, the advancing wall of crown-of-thorns starfish appears to actively avoid this specific perimeter, leaving a wide, empty buffer zone around its borders. Dropping lower into the surge, Jack peers deep into the dark, shadowed recesses of the limestone foundation beneath the healthy coral. There, hidden in the labyrinthine cracks, he discovers a scattered collection of massive, heavy shell fragments, mottled with distinctive patterns of gray and rich chocolate brown. These are the broken, weathered remains of the giant Triton snail, Coronia tritonis, a legendary, slow-moving marine mollusk that can grow up to half a meter in length. For generations of Queensland coastal communities and indigenous maritime cultures, the Triton was a symbol of the deep ocean, its beautifully spiraled, ornate shell highly coveted by collectors. To the modern chemical-fueled control teams, a handful of sea snails seemed utterly irrelevant against an army of millions of toxic starfish. But Jack marks the exact GPS coordinates, realizing that this tiny, undisturbed oasis holds a secret that completely eludes the industrial management models. The mystery lands directly on the desk of Professor Henry Caldwell at the Australian Institute of Marine Science in Townsville. Intrigued by the Rangers' field notes, Caldwell's research team initiates a comprehensive forensic investigation across multiple sectors of the Great Barrier Reef. They do not begin by studying the snails. Instead, they focus on mapping the precise spatial data of the starfish outbreaks, analyzing why certain outer reefs manage to stabilize and regenerate their coral covers years ahead of adjacent systems. Using high-resolution satellite imagery, underwater drone surveys, and historical catch records, Caldwell begins to overlay decades of marine data. As the layers converge, an undeniable, long-hidden pattern emerges on the digital maps. The reefs that consistently resist the devastating multi-year starfish cycles are not the ones receiving the heaviest chemical injections from human divers. Instead, they are the specific, historically isolated reef tracts that align perfectly with the natural, undisturbed habitats of the giant Triton snail. The discovery shifts the entire scientific perspective. The ultimate question is no longer how humanity can engineer a faster way to kill the invaders, but what ancient hidden mechanism has been quietly neutralizing them before human intervention ever arrived. To understand how a slow, armor-plated snail could challenge a highly venomous, multi-armed monster, Caldwell's team brings both species into highly controlled behavioral laboratories. What the video monitors capture in the darkness of the experimental tanks feels less like textbook biology and more like a calculated psychological thriller. The crown-of-thorns starfish, despite its formidable arsenal of toxic spines and rapid regenerative abilities, possesses an acute, highly sensitive array of chemical receptors across its tube feet. The moment a giant Triton snail enters the water column upcurrent, releasing a complex trail of predatory pheromones, the reaction from the starfish is instantaneous and driven by absolute panic. The echinoderm accelerates to its maximum physical speed, desperately trying to flee the area as its dozens of arms writhe in uncharacteristic terror. The snail tracks its prey with terrifying mechanical patience. Moving with deliberate, unhurried precision, the giant Triton utilizes its specialized, elongated proboscis to bypass the starfish's venomous spikes entirely. It delivers a highly localized, paralyzing salivary secretion that targets the starfish's nervous system, immobilizing the creature within minutes. The Triton then uses its saw-like radula to cut through the tough, leathery skin of the central disc, consuming the adult starfish completely. The contrast is spectacular. A creature designed like an unstoppable prehistoric weapon is systematically dismantled by a single patient mollusk moving across the reef floor. This remarkable revelation triggers a wave of profound optimism throughout the conservation community, igniting twist number 1. The apparent hero is completely incapable of solving the crisis on its own. When marine managers attempt to design a large-scale biological control strategy centered on breeding and releasing thousands of lab-raised giant Triton snails onto the compromised reefs, they run headfirst into a harsh, unyielding biological reality. The giant Triton snail is a natural apex invertebrate predator, meaning its reproductive cycle is slow, complex, and highly dependent on pristine, stable oceanic conditions. Furthermore, decades of unchecked human exploitation have taken a devastating toll. Throughout the mid to late 20th century, hundreds of thousands of these majestic snails were systematically collected, killed, and polished to be sold as cheap souvenirs to international tourists and coastal gift shops. The natural breeding populations have been so thoroughly depleted that the remaining wild snails are scattered across vast, disconnected distances, completely incapable of matching the sheer exponential velocity of a modern crown-of-thorns starfish outbreak. This realization forces the scientific community to look deeper into the blue, revealing twist number 2. A much larger, invisible ecological force is operating entirely behind the scenes, and humanity has been fundamentally misdiagnosing the true engine of the catastrophe. As Caldwell's team expands their water quality sampling across the entire Queensland shelf, they discover that the explosive population booms of Acanthaster cf. Solaris are not an isolated wildlife phenomenon. They are the direct, inevitable symptom of a profound land-based ecological imbalance. Every summer, heavy tropical monsoons wash millions of tons of agricultural runoff, industrial fertilizers, and untreated livestock waste from the massive river basins of northern Queensland directly into the ocean. This massive influx of dissolved nitrogen and phosphorus creates a colossal, hyper-accelerated bloom of microscopic phytoplankton across the inner and outer reefs. While an adult starfish is a visible, terrifying monster on the coral, its vulnerable, microscopic larvae float in the water column for weeks, entirely dependent on phytoplankton for survival. In a natural, balanced ecosystem, over 99% of these larvae starve before ever reaching the reef floor. But within these human-engineered nutrient plumes, the food supply is suddenly infinite. The larval survival rate skyrockets by more than 1,000%. Unleashing a colossal, invisible tidal wave of juvenile starfish that completely overwhelms the natural carrying capacity of the marine environment. The war, it turns out, does not originate on the coral reefs. It is manufactured deep within the soil of the mainland, driven by the way modern society manages its coastal rivers and industrial landscapes. This revelation brings forward the final twist, completely reframing the entire documentary arc. The enduring story of the Great Barrier Reef is not actually about eradicating a venomous predator, achieving a definitive human victory, or returning the marine environment to a static, idealized past. The crisis forces us to confront a deeply humbling, evolutionary truth about our relationship with the wild. The crown-of-thorns starfish is not an alien invader. It is a native, ancient component of the Pacific ecosystem that has existed for millions of years, historically functioning as nature's wild lumberjack. In an undisturbed ocean, its periodic outbreaks served a vital structural purpose, selectively consuming the fastest-growing, aggressive hard corals to clear physical space and allow slower-growing, highly diverse coral species to establish their own footholds. By hyper-fertilizing the water column while simultaneously removing the apex predators like the giant Triton, human engineering didn't just create a pest problem, we accidentally rewired the underlying evolutionary logic of the entire marine landscape. The ecosystem is no longer operating under our rigid management templates. It is actively reorganizing its entire internal architecture to survive the permanent, nutrient-dense reality of the modern Anthropocene. The epic conflict beneath the waves remains entirely open-ended, a dynamic and unpredictable evolutionary arms race with no clean resolution in sight. Out on the white, sun-bleached perimeters of the outer shelf, the chemical-laden spears of human divers continue to strike individual starfish, an expensive, desperate attempt to micromanage a crisis that spans thousands of miles of open water. But deeper down, along the shadow-drenched margins where the hard coral meets the open deep, the true architecture of the future is being quietly negotiated by the organisms themselves. The remaining wild Triton snails are adapting their hunting ranges, moving into highly concentrated sectors where the starfish density is highest. At the same time, specialized reef fish like large sweetlips and nocturnal triggerfish are beginning to alter their traditional diets, learning to exploit the abundance of juvenile starfish before their defensive spines fully harden. The Great Barrier Reef is not a fragile, passive victim waiting for human rescue. It is a highly intelligent, self-correcting biological engine that is stubbornly, quietly rewriting its own rules of survival under the immense weight of a changing planet. If the incredible resilience of our native marine ecosystems and the hidden, complex victories of the natural world resonate with you, leave your field notes and thoughts in the comments section below. Do you believe we should continue to pour millions into artificial, high-tech engineering fixes? Or is it time to humble ourselves, reform our land use policies, and trust the independent wisdom of a self-repairing ocean? Let's keep the conversation and the wild alive, and we will see you out there on the next line of the frontier.